Hi everyone, this is the demo for my unofficial guide, Retrieval Augmented Generation System, built for Columbia University graduate dining and meal plans. In this demo, I will walk you through three queries, highlighting our system's strengths and limitations, and finish with a walkthrough of the evaluation report. First, let's start the system, and I use PowerShell here, use Python app.py to start. Let's wait for it to start. Now you can see it's loading the sentence transformers model and connecting to Chroma database. And the session already started on the local host. Let's click it. And you can see the session here. Here are some 7 questions, and I will go through it real quick. So for my first query, I will ask, can graduate students use their meal plans at John J. Ferris or JJ's? This is a major pain point for grads, as official websites often gloss over this restriction. As you can see, the system outputs a clear graduate students cannot use their meal plan at John J. Ferris or JJ's Place. Their meal plans are not restricted to select retail locations like Chef Mike's and faculty halls. So you can see the restricted locations here, and it also pragmatically cites our source, the S10 Reddit grad policy here. If we look at the retrieved sources list on the right, the system successfully pulled the Reddit discussion summarizing the policy shift. Behind the scenes, the top retrieved chunks are highly relevant, explicitly starting that grad plans do not include traditional residential dining halls. The rec pipeline worked perfect here. And let's continue to the second question. Let's ask a policy detail. What happens if I run out of meals before the end of the term? Can I buy more? And the system successfully retrieves details from student guides and forum Q&As. Reddit extra meals, Park Meal Plan Guide 2025. I think the retrieved chunks are directly aligned with the policy options, showing that our custom paragraph-based chunking with 150 characters of our life successfully preserved price lists and expansion pack rules. Now let's test a query where the system might be struggle about. I think that should be if I have most of my classes in mod, which on campus dining locations are most convenient for grabbing lunch. Ideally, the system should list Blue Java in mod, Chef Don's in mod, Chef Mike's in URIs, and faculty house at the same time because they were placed nearby and they are the same good places to go. But you can see here, our system generated response only suggests faculty house. It completely missed Blue Java and Chef Don's here. There, you can see here, therefore I do not have enough information on that. In our trunking stage, we split the official C's guide, the guide here, as for engineering dining into very small chunks one for each specific dining location, and the chunk were too small and separated. Our similarity search only retrieved introduction chunk and the faculty house chunk. The other mod ejected location chunks were ranked lower and cut off, leaving the RLM with incomplete context to answer the question. I think to fix this retrieval failure, we just need to merge these location list items into larger single directory chunks so they always got retrieved together. I think that might be helpful. To the evaluation report here, you can see in the README, we have evaluated the rec system using our 5 test queries. As we saw in the demo, Question 2 about Ferris and John Jay scored accurate in retrieval and generation. And question 3 about adding extra meals also scored accurate because the paragraph overlap kept the 10 meal pack details intact. However, this question, the question 4 about mod-adding, was marked partially accurate due to the chunk fragmentation we just analyzed. This evaluation shows that semantic search is highly dependent on chunking boundaries. Moving forward, I plan to optimize the vector index by implementing hierarchical chunking for location directories. And I think the second important thing is that I just installed all the requirements directly into my system environment, and I forgot to use the virtual environment instead. And I think using UV to instead of pip might be helpful because I've heard of the virtual environment of the UV is better than using pip, and I definitely will try it after I submitted this thing. And thank you for watching my demo.